In traditional server-side applications, the application would check permissions on the server and return perhaps a 403 error page if the user didn't have permissions. Or maybe even redirect them to a login or register page if they weren't logged in. And with SPAs, we want to have similar functionality. And with router guards, we can. With router guards, we can prevent users from accessing areas that they're not allowed to access, or we can ask them for confirmation when leaving a certain area. By the end of this lecture, you're going to know the 4 different types of router guards. You're going to know how to implement router guards as functions. And you're also going to know how to implement router guards as classes. And we're going to go through a specific example for implementing a login guard for our iTunes app. So in this lecture, we're going to take a look at a few of the different types of guards and how to implement them for a specific use case. One use case is that maybe the user must log in. Perhaps they need to authenticate first before viewing a certain page. Or perhaps the user has already logged in but is not authorized to navigate to the target component. Or maybe we want to ask the user if it's okay to discard pending changes rather than save them before they navigate away from the page. There are 4 different types of guards that we can create. We have the can activate guard, and this checks to see if a user can visit a route. We have can activate child, which checks to see if a user can visit a route's children. We have can deactivate, which checks to see if a user can exit a route. And we have something called a resolve, which lets us retrieve some data that we require to show the route before the route is activated. And we also have the can load guard, which checks to see if a user can route to a module that is lazy loaded. And for any given route, we can implement 0 or any number of guards. Now we're only going to go through the first 3 in this lecture. The last 2, the resolve and can load, are very advanced use cases, and they need lazy loading modules, which we haven't covered yet. But the overall concept is pretty much the same. So the first one we're going to implement is a can activate guard. Guards return either true if the user can access a route or false if they can't. They can also return an observable or a promise that later on resolves to a boolean in case the guard can't answer the question straight away. For example, it might need to call an API to check if a user has permission to do something. And Angular will keep the user waiting until a guard returns either true or false. Now let's create a simple can activate guard. The first thing to do is to import the can activate interface. It comes from the router module, so we import it from there. And I'm going to create a guard called always auth guard, and it implements the can activate interface. Now the can activate interface has one function called can activate, so that's the function that we're going to add in to our guard. And all I'm doing for now is logging out the fact that the can activate function was called, and then I'm going to return true. So this guard returns true all the time, so it doesn't really guard anything. It's going to let all users through all the time. But at the same time, it's still going to log always auth guard to the console, so at the very least, we're going to be able to see when it's being used. Now we need to provide this guard. So for this example, let's just configure it on our ng module providers. So we go to the bottom, and I'm just going to add it to our list of providers. And finally, we need to add this guard to one or more of our routes. Let's just add it to the artist component route. So if we go back to the route configuration, I add a property called can activate, which will hold an array. And inside this array, I put the always auth guard class name. Essentially, this is going to be the token that it's going to try and resolve a guard with by using the Angular DI framework. So an important thing to note, since it holds an array, it means a root can have any number of guards associated with it. And Angular will try and execute every guard in order. So only if all of the guards return true will we be able to navigate to that root. So now if I rerun the application, and let's open up the console as well, clear it. And now if I navigate to the artist component, if we scroll up, we can see that always auth guard is now printed to the terminal. So at the very least, we know that the guard is working. So the most typical use case for something like the canActivate guard is some form of checking to see if the user has permissions to view a page. Now, normally in an Angular application, we would have some form of service which holds whether or not the current user is logged in, or perhaps what permissions they have. So to simulate this, I'm going to mock a user service. So I'm just going to put this at the top of our page. Here we go. So I'm just adding in a class of user service. It just has one function called isLoggedIn, which returns false. So it basically is signaling that this user isn't logged in. Now, just a quick note, I'm not adding injectable to these classes because we're not injecting anything into these classes. We only need to use the injectable decorator when we're injecting something into the constructor of a class. We're not injecting anything into the constructor of this class, which is why I'm not adding the injectable decorator. But we do need to provide the user service just like we're providing the guard. So I'm going to add it to our ng modules at the bottom there. And I'm going to create another guard called only logged in users guard, which only allows logged in users to view a root. If I scroll up to my guard section, it's going to be called only logged in users guard. It still implements canActivate, but inside this guard, I want to refer to the user service, to the instance of the user service that I want Angular to inject in. So I need to add a constructor, and in our constructor, I add a reference to the user service. So this is going to trigger Angular to give us an instance of the user service. Then in my canActivate function, I then check to see if the user is logged in. If they are, I'm returning true, which will pass this guard and let them view the page. If they're not logged in, I'm going to show a window alert, and I'm going to return false to stop them from being able to navigate to that page. And I also need to make sure I provide this guard and also configure it on the roots. So let me first configure it on the roots. I'm just going to prepend it to our list of canActivate guards. And I'm just going to add it to the list of guards in my providers at the bottom there. And there's one more thing I need to do. Because we've injected something into the only logged in users guard constructor, I need to decorate it with the injectable decorator. So now if I rerun the application, I'm trying to visit the artist page, the artist tracks page, and it's telling me you don't have permission to view this page because we're hitting the guard and we're failing because the isLoggedIn function of the user service returns false. It's hard coded to return false, and that's why we're getting this alert being shown to us. And for now, it's basically not letting us navigate to that page. But if we were navigating from the search page, clicking in, again, it's just going to show us the alert, and it's just going to leave things as they were. We're not actually going to navigate anywhere. So on its own, not really that useful. If we wanted to redirect users to a login page, we could additionally inject the router into our constructor and then just navigate them to a login or sign up page from the failure case here, when the router guard fails. Okay, so for the rest of the samples in this lecture, we're going to change the isLoggedIn function on our user service to return true instead. And if you want to play around with this functionality later on, remember to switch this back to false in the future. So I'm just going to switch this to true so it lets us through. As well as canActivate, we can also have canActivateChild, which we implement in a very, very similar way. So I'm going to create something called an always_auth_child guard. Scroll down to where I'm putting in all the guards. Here we go. That's very similar to the always_auth guard. We implement something called a canActivateChild. This then also has a function called canActivateChild, and all I'm doing right now is I'm just logging something to the console and returning true. Because we're implementing this interface, I need to import it. And because it's a guard, I need to provide it on our ng module. Where is this? Here. So I'm going to provide it on the ng module, just there. And also I'm going to add it to our routing configuration. I'm going to add it to the canActivateChild property on our artist component. And for now, I'm just going to remove or comment out the canActivate guards. So now if I clear the console, let me refresh the page. Okay. Now if I go into an artist page, scroll up, you can see the always_auth_children guard is called. That's because we're trying to view the tracks, the child component, essentially this one here. When it tries to render this component, it's going to check this guard to see if it has permission to render this component, this child component. So again, if I click on albums, scroll here, you can see it again, we're seeing always_auth_children guard being checked again and again and again. So essentially, this guard is called every time we want to check whether we can show a child component. So to help in determining whether or not a guard should accept or deny access, the guard function can also be passed a couple of different arguments. We can pass an instance of the component, and this is the actual component which is going to be injected into the page. We can pass something called an activated route snapshot, and this is the future route that will be activated if the guard passes. And we can use its params property to extract the route parameters. And we can also pass it an instance of the router state snapshot. This is the future router state if the guard passes. And from this, we can find the URL we are trying to navigate to from the URL property. Now, the third type of guard we can add to our application is a canDeactivate guard. And we usually add this guard to warn people if they are navigating away from a page where they have some unsaved changes. Now, we're going to create a really simple canDeactivate guard. Not a very good one, but a really simple one, which checks to see if the user navigates away from the search page without actually performing a search. Now, firstly, I'm going to create a function called canDeactivate on our search component. And it really should be the component itself that decides whether or not it has unsaved changes. So I've added a very simple function to our search component. It's assuming that if the results array on our search service has more than 0 items, then it can deactivate, as in we can move away from this. So therefore, if we've never performed a search, our results length would be 0, and therefore canDeactivate would return false. Now this is a very simple and not very good way of checking to see if we can deactivate. But just to demonstrate the guard, it's a pretty good approximation. Now, to implement the can deactivate guard, we need to import the can deactivate interface. So let's add that first to the top of our file. And I also want to use the activated root snapshot and router state snapshots. I'm going to include those as well. So now let me go down to where I'm implementing all of the guards. Is just here. So I'm going to create a guard called unsearched term guard. Now it implements from the can deactivate interface, but this is a generic interface. So to the can deactivate interface, we additionally provided the type of our component. The type of our component is the search component. So I'm going to pass that in. Now it needs to know the type of the component because it's going to pass that in to our can deactivate function. So the first parameter it passes in to at the can deactivate function is the component itself. Now this isn't happening via Angular's dependency injection framework. This is just quite literally being passed in as function parameters. Now in addition to that, I also want to get the other parameters, the activated root snapshot and the router state snapshot. So let me add those in. And for now, I'm just going to log out some useful information to the console. I'm logging out the fact that we're checking to see whether the user passes the unsearched term guard. I'm also just going to print out the activated root snapshot parameters, and I'm also just going to print out the state URL. But the main logic for our application is going to be from the component itself, the search component. I'm checking to see if we can deactivate. If that returns false, it will show a window confirmation message, are you sure? So I need to do everything else. I need to provide my unsearched term guard. And I'm also going to add it onto my search route here. Can deactivate unsearched term guard. So now if we refresh the page, I navigate to search. I haven't actually performed the search. If I try and navigate to home, it's going to say, are you sure? If I click OK, it lets me navigate to home. So to summarize, with guards, we can add checks to restrict access to users to certain pages on our site. And depending on the type of guard, the guard function also has some arguments passed to it, namely the future activated root and the future router state. And for can deactivate guards, we can also have the ability to get the component itself. Now guards themselves are just classes, and as such can have any other dependencies injected into their constructor, so they can work in conjunction with other services to figure out if the guard passes or fails. Guard functions can return either a Boolean or an observable or a promise which resolves to a Boolean at some point in the future. And a root can be configured with multiple guards, and the guards are checked in the order they were added to the root. Now we're almost complete with this section on routing. In the next lecture, we're going to cover the concept of path strategies.